Welcome everyone to our lecture on projectile motion and its questions. So in the last video we discussed a lot about projectile motion and how we are trying to derive the equations in a projectile motion and what are some final expressions. So the final expressions which we came about were the time of flight of the particle, which is 2v sine theta upon g, the maximum height and the range. So in this particular lecture we are going to apply those concepts and different ideas, and we are trying to learn a bit more. So let us start. So we'll be starting with the question, and this is an example. A particle is fired at an angle of 30 degree with the horizontal with a speed of 10 meters per second. Take g is equal to 10 meter per second square. Find the time of flight of the body, find the maximum height, and find the range. So we are given everything looks like. We are given the velocity is 10. The velocity is 10 meters per second. The acceleration g, actually gravity g, is given as 10 meter per second square, and we are projecting the ball at an angle of 30 degree with the horizontal. So we are supposed to find each and every value expression which we are looking for: the range, the maximum height, and the time of flight. So first let us look for the time of flight. Time of flight is simply 2v sine theta upon g. So we will substitute the value of v, velocity, that is 10, sine theta, that is sine 30 degree, action to gravity g is 10 meter per second square. So after substituting everything, we can cancel velocity and g, and this would come out to be simply 1 second. That means it would take only 1 second for the body to start its motion and come back and strike the ground again. Next, we are supposed to find the maximum height, h max. H max is simply v square sine square theta by 2g. Velocity of the body is 10 meters per second. So we will be squaring it: 10 square sine square 30 degree divided by 2 times the action to gravity, which is 10. But this would gives us h max. So h max is equal to 100 upon 20, which is 5, and sine square 30 degree, which is 1 upon 4 meters, that is 5 by 4 meters. Range is equal to v square sine 2 theta by g. So r is equal to velocity square, that is 100, into sine 60 degree divided by action of gravity, which is 10. Since theta is 30 degree, the angle of projection is equal to 30 degree, then 2 theta becomes 60 degree, and v square is 100, action of gravity g is 10. So this comes out to be some 5√3 meters. So this is the range to which the body would travel to. So this is the range. This is the maximum height of the body, which is the maximum distance from the ground which the body would reach, and r is the range, the horizontal distance it would travel before it is striking the ground, and 1 second is the time. So this is what we have calculated. So the answer, 1 second, the maximum height here is 1.25 meters, which is 5 by 4 meters, and the range is 5√3 meters. Let us take a next example. So in the next example, we are given that a ball is projected at an angle so that its range is maximum for the given angle. So this is what we calculated in the last video, at the end of the video, that what is the maximum range to which the ball can be thrown. The maximum range to which the ball can be thrown is actually found when we are taking the angle of projection as 45 degree. This is what we proved. We took sine 2 theta equal to 1 and found that 2 theta has to be equal to 90 degree, because sine 90 is equal to 1. So theta came out to be 45 degree. And then we concluded that at this particular angle, the range achieved by the body at some given velocity is maximum. So what we are going to do here we are already given to it is given to us that the range is maximum for the given angle. So what would that angle be? That angle be 45 degree. The velocity of the particle is 10. Find the maximum height of the particle. So we would take the formula of maximum height, that is h max. H max is equal to v square sine square theta divided by 2g. So v square is simply 10 square, as the velocity is 10, sine square 45 degree divided by 20. So that would be 100 upon 20 divided by 1 by 2. So that would be simply 10 upon 4 or 5 by 2 meters. Let's do next. So now we are actually going to continue our derivation from the last video. So we were able to arrive at the equations x is equal to v cos theta t plus 0 into t square, since there is no acceleration in x direction, and y is equal to v sin theta into t minus half gt square. So these were the main equations which we learned that these were the which we learned that these equations would be most useful. So now what we want to do is that we want to remove the variable time from both the equations. We want to remove this variable. So let us see what happens next. So let us find the value of t from this equation. So t is equal to x by v cos theta. Now we will be putting the value of t in the second equation. So let's say that y is equal to v sin theta into t, which is x upon v cos theta, minus g by 2 into x upon v cos theta and square. So by doing this, we have eliminated the value of t from both the equations. So here we can easily cancel v. So this would come out to be x sin theta by cos theta, which is tan theta. So y is equal to x tan theta minus g by 2 x square upon v square cos square theta. So we have arrived at some equation. So now this equation at first does not seem that much useful, but let us compare and try to learn its use. So y is equal to ax plus bx squared, and let's say c is 0 for this case. Now we knew that this is the equation of a parabola. And if you look carefully, the equation above it is just like what we have already written below it. So the equation above it is y is equal to x tan theta, and the power of x is 1 in the equation above, and in the equation below also the power of x is 1, and again in the second term the power of x is 2, and also in the equation above it, that is the equation of path of the body as it travels through the air, the x to power is also 2. So these equations seem quite comparable and are matching. So this gives us the idea, or this eventually gives us the hint that when we are throwing a body in space at some angle on earth at some angle, then this would be a parabolic, then its path would be a parabolic path. Now why would it be a parabolic path? It would be a parabolic path because it is following the equation of a parabola. Equation of parabola has ax plus bx squared, and the equation of the path of the body is y is equal to x to the power 1 some constant in x square into some constant. Now negative sign does not matter that much, but the important point is there is x to the power 1 and x square, so that's why it's a parabolic path. So this is also called the equation of trajectory of the projectile. And by trajectory we mean the path of the projectile. This is the path of the projectile. Okay, so we are supposed to actually continue our derivation. Continue this derivation. So we'll be starting from the point y is equal to x tan theta minus g x square 2 v square cos square theta. So what we do here is we will multiply sine theta and divide it by sine theta. So this should come out to be x tan theta minus 2v square sine theta from this expression, 1 cos theta from this expression, and 1 cos theta comes out. So the denominator is complete. 2v square, 1 cos theta here, 1 cos theta here, and 1 sine theta here, x square and sine theta. As you can see, we are looking at the theorem of sine theta by cos theta in both the terms, so it would come out to be a common. And if you recognize this expression 2v square sine theta cos theta by g, this is actually called the range of the motion of the body, and it is inverted in this expression. So we say that x tan theta is simply a common, taking common, so there is 1 over here, x divided by this whole term. This whole term is range, is 1 upon range. So this comes out to be r. X and tan theta have been taken outside, they are common. So this is our equation. Y is equal to x tan theta 1 minus x y r. So this is one more form of equation of trajectory which we can use. And we would say this is easier to remember than the previous one. Okay. So let us go back to our slide. So we are starting with the questions. First question which we have is, a ball is projected at a speed of 20 meter per second at an angle of 30 degree. So now the question which we would be doing would be of application of our ideas which we have learned, rather than simply using the formulas. So previously we only used the formulas of range, height and time of flight, so they do not require much analytical power, just memorization power. So now let us see what we have on our plate. Let's do some questions. The first question is, a ball is projected at a speed of 20 meter per second at an angle of 30 degree. Now find the speed with which a cart should be pushed on the horizontal floor so that it catches the ball. What is happening here is that you have a ball. That ball is being projected at some angle. You have a ball over here. That ball is being projected at some angle with some speed. And there is a cart beneath the ball. Now as the ball is being projected, what we are asked to do is that as the cart also progresses further, then when the ball is about to hit the ground, the cart should land just beneath it, and it should be able to capture the ball. So you should just read the language of the question. The cart is slightly bigger than the ball, and so that it catches the ball. The cart must catch the ball. The ball is going at a speed of 20 meter per second and it is projected at an angle of 30 degree. It is projected at an angle of 30 degree and it is going at a speed of 20 meters per second. So okay, after having understood the question, what idea do you think from what we have learned can be applied here? So one idea which we learned is that we can write the equations by simply putting uxt half axt square, uyt half ayt square for x and y. One idea which we learned is to first think about what is the horizontal velocity of the body, what is the velocity of the body along the line of projection. So what is this particular velocity and what does this mean? So we know that as the body moves in forward direction, it has no acceleration in this direction, so it won't be accelerating, and it would be the same case with the cart also. As the cart is moving forward, it won't be accelerating either. That means the body and the cart, if they were to move at the same velocity, then the body, when it comes back to the horizontal level, then the cart would be able to easily catch it, right? Because both they have same velocity, there would be same horizontal velocity, there would be no horizontal separation. In fact, the cart would see the ball just going up and down and would simply catch it because there is no motion of the body. Nobody is trying to get ahead or nobody is lagging behind in motion. So if we were try to find the horizontal velocity, we know the horizontal velocity is given by v cos theta, which is simply 10 root 3 meters. that is 20 cos 30 degree. So this is the velocity, horizontal velocity of the ball. Therefore the card must have the same velocity. If it is trying to reach the card. So this is our option C, 10 root 3 meters per second. So let us do one more question. A particle is projected at an angle that the maximum height and range for the relation r is equal to 4h. Again, this is a formula based question and can be done very easily. We are given that the relation between maximum range, between range and height is r equal to 4h. Now r is equal to v square sine theta cos theta into 2 divided by g. H is equal to simply v square sine square theta divided by 2g. So if we were to take the ratio of r and h, what we would get? So if we were to take the ratio of r and h, we would get 2 cos theta divided by sine theta by 2. That would be 4 upon tan theta. And r is equal to 4h. So that means if you were to compare this and this equation, tan theta would simply be 1. If tan theta is 1, r would be equal to 4h, right? So tan theta is 1, that means the angle at which the particle is projected is 45 degree. So 45 degree would be the correct answer. So let us begin with further questions in the next video, and thank you for attending this lecture.